We did the setup. Now let's go ahead and look at this neuron making a decision whether or not to fire an action potential, okay? I use an example for this. My friend, former student Jill, who's now a nurse. Jill is a gym rat. She hangs out a lot at the gym, in great shape. And she's a good looking kid, so all the guys hit her at the gym. She wears earbuds so she can pretend she doesn't hear them. But there's one guy she's seen at the gym for several years, and she's talked to him. He's okay. They actually went out hiking a couple of times. Jill let him know that, she was willing to be his friend, but there was not any romance in the future. He said okay, he understood that. One day at the gym, he came up to her and said, "Hey, Jill, I got tickets for the Rams versus the Eagles in LA game, NFL. You want to go?" Jill said, "That sounds interesting." She says, "How's it going to work?" He said, "Well, we'll leave here on Friday, just kind of see the sights in LA on Saturday, go to the game on Sunday, drive home." She said, "Okay, so where do we stay?" He says, "I got a hotel room." She said, "Just one?" He said, "Yeah." She said, "How many beds?" He said, "Just one." Jill said, He said, "It's okay, we'll draw an imaginary line down the middle. You sleep on your side, I'll sleep on my side." So now Jill's going, let me think about it. Okay, so Jill is like the neuron that has to make a decision. Fire the action potential or don't. Go to LA for the game or don't go to LA. So what did Jill do? She started asking her friends. So some of her friends said, "Jill, YOLO, girl. You're grown up, you can take care of yourself, you should go. This is a once in a lifetime experience." So that would be like a +9, all right? These are millivolts, all right? So it doesn't really matter, but all right, so yeah, maybe other friends said, "Oh gosh, Jill, I don't know, sounds kind of weird, but yeah, maybe you should go." All right, see? Different amounts of emphasis, all right? Some people, yeah, others, I don't know, Others said, "Oh yeah, Jill, I've seen, he's got a nice car, should be a nice road trip, cruising around LA. Yeah, okay, it sounds good, all right." Another friend said, "Yeah, Jill, I know this guy makes a lot of money, all right? Probably take you some nice clubs, take out to dinner at a nice place. Ooh, that sounds good, yeah." And somebody else says, "Yeah, Jill, I know this guy. He's really nice to his mom." Yeah, well, most people are nice to their mom. That doesn't tell you much. "Yeah, Jill, I saw this guy. He was helping an old lady across the street with her groceries." Well, that's a nice thing to do, okay? So see, lots of friends are saying, "Yes, go. We think you should go," all right? So lots of friends saying, "Yeah, do it. Go. Girl, you should do it." Other friends are going like, "Jill, I don't know. My cousin's sister's brother's girlfriend said that he was really mean to his ex." Yeah, well, lots of people are mean to their ex, but maybe that's like a -2. Somebody else said, "Yeah, Jill, I worked out next to this guy at the gym one time and he wears that Axe body spray." Ugh. That's like -5. Another one said, "Yeah, Jill, my brother knows this guy. I heard he watches a lot of porn." Ooh, nah, that's not good. All right. So, and a couple other friends also chimed in and said, "Yeah, Jill, I'm not sure you should do this. Doesn't sound like a good idea." Okay. So, Jill got advice from her friends. What do we do now? What do you suppose we should do? Shouldn't we maybe add them up? All right. So let's add up the positives. 9, 10, 18, 27, 29, 34, 41. So we get +41 in terms of the votes that say, "Yeah, go." And then negative, we get 7, 14, 15, we get 18, so that's -18, all right? So if you add +41 and -18, what do you get? I know you all made it through the 4th grade. Take off your shoes if you need to. This is going to be +23, isn't it? All right? So we end up with a +23. So overall, the votes say, "Yeah, go, do it." But is that enough? What if it were +1? Would that convince you to go? I don't know. What if it were +200? Yeah, probably. +23, is that big enough or not? Well, the neuron has a way of dealing with that. Remember, there is a default charge in the axon hillock. Remember, it was called the resting membrane potential. It's around -70 millivolts for a typical central nervous system neuron. So what we're actually doing is, you see, all of these graded potentials were all flowing down the dendrites, okay? They were flowing down the dendrites, and they're all converging in the axon hillock. That's what's going on here, all right? So they all come together, and so this is modifying the resting membrane potential in the axon hillock. So what we have to do next is we have to say, all right, it was at negative 70. Now we add positive 23. And what does that give us? Once again, take off your shoes if you need to. I think, isn't that going to be a negative 47? I hope so. If not, you can make fun of me, and that's fine. You can't hurt my feelings, I don't have any. So overall, and these are millivolts, by the way. So overall, we get negative 47 millivolts. Well, what does that mean? How does that help? Remember, in order for the neuron to decide whether to send out its own action potential, there was a magic value that if it made it over that value, that it would send out the action potential. What was that value called? Threshold. And what was that value? Negative 55. That's one of the numbers I told you had to know. So let's make a little graph here, a little chart. So here we've got negative 70. That's the resting membrane potential, right? Here's negative 55. That's threshold, all right? That's what we have to hit. Threshold. Oh, God. That's just pathetic, isn't it? Let's see if I can do a better job with that. Threshold. There is threshold at negative 55. And so in this case, oh my God, this is just, you're watching me decompose right in front of you. So in this case, where is negative 47 going to show up? Where does that go? Where on this graph will that be? Negative 47 is going to be up here, isn't it? So what do you think? Did we make it above threshold? Yes, we did. And so what happens in this particular instance that we just went through? Yeah, we fire an action potential. Action potential fires. Neurotransmitters get released. See how easy that was? That's how it works. Now, you can still kind of go, so what? Well, you have billions of neurons, all right, in your brain, in your nervous system. Somewhere 80 billion to 100 billion, something like that. They argue about how many. But what's happening is every one of those neurons is connected to 1,000 on average, maybe, of other neurons. And this is happening every moment in time. In other words, what we just went through took one moment to happen, and the next moment is a whole different set of values. All these billions of neurons are all connected to one another. This is happening hundreds or hundreds of times per second, all right? And so that's, we think there's like a little person in our head who's, thinking and looking at things and making decisions, but no, it's not. It's just all these neurons. It seems like there should be more to it, but it isn't. This is what it is. This is billions of neurons doing this at every moment in time, and that's everything that you are and everything you do. That's all of your memories, that's all of your emotions, that's all of your thoughts, that's all of your movements, all right? This is algebra. This is poetry. This is love, all right? So forget that green-eyed bitch. It's nothing more than chemicals and electricity in your head. Just get over it, okay? So this is basically what it comes down to. Look this over a couple times because this is essentially what the nervous system does. And if you get this, you are in really good shape. And I'll probably ask you about some of these steps at some point, okay? Text or email me with questions.